Hello, welcome back to Mr. Kendrick's online math class. This is a continuation of lesson 3.2, factoring expressions. Go ahead and turn to the next blank page in your math notebook and put this title at the top. And throughout this lesson, you'll be writing down 6 different things in your notes. Some are rules, and then the rest will be worked through examples. Alright, so for the rules for factoring expressions, when we factor an expression, we're going to write the expression as a product of factors. And when we're factoring an expression, we've been working with the distributive property to distribute terms throughout the expression. Factoring is basically undoing that distributive property. So our answer must be written with a number in this form. So a number outside of the parentheses with an expression inside. And one of the ways that we can do this is using a method called upside down division. So what that means, instead of having the division sign going this way, we're actually going to use it the opposite way. In this example, we have the expression 3x plus 9, and we need to factor out the biggest number that goes into both of these, the 3x and the 3. So for this one, both of these terms can be divided by 3. So if we divide 3x by 3, that will leave us with 1x, and 9 divided by 3 will leave us with a positive 3. Okay, so in this one, our factored expression would be 3 times 3x, or 3 times x plus 3. So again, we're going to focus with this upside down division method, and our goal is to pull the biggest number out of the expression that goes into all the terms in the expression. Okay, so go ahead and pause now. Make sure you get these notes and example written down in your math notebook. Alright, so what we're really trying to do is we're trying to undo the distributive property and create an expression in its simplest terms. So for this one here, I would like you just to watch, and then you can write down the example when I'm finished. In this problem, we're trying to factor out the greatest common factor. So the greatest common factor is the biggest number that goes into both of these terms. In this one, we can just start by listing the factors. So for 24, it would be 1 and 24. 2 and 12. 3 and 8. And 4 and 6. For 18, it would be 1 and 18. 2 and 9. 3 and 6. And then if we look at these factors, the greatest number that goes into both of them would be 6. So now if we factor out that 6, we would have 24x minus 18. And then we're going to do the upside down division, factoring out the 6 over here. And then we would have 24 divided by 6 would be 4. 4x, and negative 18 divided by 6 would be negative 3. So now our factored expression would be 6 times 4x minus 3. Okay, so when we're factoring out the greatest common factor, we can use this method to find the factors, which is referred to as the rainbow method, because you kind of get that rainbow shape. The other one we can use is called boat division. And so the way that would work is if we had the expression 24x minus 18, and we don't get to the greatest common factor right away. So let's say we put this expression into a boat, and then say we know that these two are divided by 3. So we'll start with 3. 24 divided by 3 would give us 8x, and negative 18 divided by 3 would give us negative 6. Okay, so now if we look at this factor, we see, or this expression, we see that there's still, both of these are even, so they can be divided by 2. So we put it in a boat again, and then we divide by 2, and we would get 8x divided by 2 would leave us with 4x, and negative 6 divided by 2 would leave us with negative 3. So you can see we get to the same answer, but the way we find our greatest common factor is if we multiply these two. Okay, so that would 3 times 2 would be 6, so we would get 6 times 4x minus 3. Okay, so either way works. Whichever way makes the most sense for you is the one that I would like you to use. So make sure you get this example written down in your notes. Alright, so now that you have this example down in your notes, I would like you to try a couple on your own. So for both of these, we're trying to factor out the greatest common factor, the biggest number that goes into both of them. So go ahead and pause here, try A and B, and then push play and see how you did. Alright, for A, the greatest common factor in 10 and 5 would be 5. So if we use the upside down division, we pull out a 5. 10 divided by 5 would leave us with 2, and 5 divided by 5 would leave us with 1, plus 1. So our factored expression would be 5 times 2 plus 1. For example B, I'm going to put the expression into the upside down division, or into the boat, and for 28 minus 40, I know both of these go into 4, so I'm going to start with 4 as the factor. 28 divided by 4 would leave us with 7, and negative 40 divided by 4 would leave us with negative 10. And then no other factors in 7, so we know that this was as far as we could go, so our answer would be 4 times 7 minus 10. Alright, so these were a couple expressions without a variable. We had a couple more examples for you to try on your own, and then come back and see how you did. So go ahead and pause here, try C and D. We're factoring out the greatest common factor. For C, if we look for the greatest common factor for 24, we would have 1, 24, 2, 12, 3, and 8, 4, and 6. And then for 28, we would have 1 and 28, 2 and 14, 4 and 7. Alright, and there we can see the greatest common factor between both of them would be 4. So we're going to use 4 as our greatest common factor. So we'll get 4 here. 24x divided by 4 would leave us with 6x. And negative 28 divided by 4 would leave us with negative 7. So our factored expression would be 4 times 6x minus 7. And for D, I'm going to go ahead and use the boat division. So we're putting our expression into the boat, and I'm going to start by dividing by 2. So divided by 2, 18m would be 9m, and negative 36 divided by 2 would be negative 18n. And then I know both of these are divided by 3, or divisible by 3, so I'm going to put it in the boat again and divide by 3. And 9m divided by 3 would leave us 3m. And negative 18 divided by 3 would leave us 6n. And then I see that we have a factor of 3 again, so I'm going to, in the boat again, and divide by 3. So 3m divided by 3 would leave us with m, and negative 6n divided by 3 would leave us with negative 2n. Okay, so now we have our expression simplified as far as we can go, and then we need to figure out our greatest common factor by multiplying. 2 times 3 is 6, times 3 would be 18. Okay, so then our final factored expression would be 18 times n minus 2n. Alright, the fourth thing we're writing down here is this example. We're trying to factor out negative 2 out of negative 4g plus 10. So if we get negative 4g plus 10, and we're going to put it in the boat and divide by negative 2. Negative 4g divided by negative 2 would leave us with 2g, and 10 divided by negative 2 would leave us with negative 5. So our factored expression would be negative 2 times 2g minus 5. Because we have a negative divided by a negative, we get a positive here for 2g, and we have a positive divided by a negative, so we get a negative minus 5 there. Alright, for 5 here we got some definition for coefficient, which is just the number connected to a variable. And if we look at this expression here, the 3 would be the coefficient, x would be the variable, and 8, any number that is just by itself, is called a constant. So go ahead and pause here, make sure you write these terms down, coefficient, variable, and constant in your notes. So now our focus is going to be factoring out a variable. So as long as you got these, if you understand the coefficient, variable, and constant, we will look at some examples to factor out the coefficient of the variable. So for the first one, we have 4c minus 1, and we need to take out the coefficient, so that 4 next to the variable. So if we draw our little boat here, and we are factoring out the 4, because that's the coefficient next to the variable, we would be left 4 divided by 4, or 4c divided by 4 would leave us with c, and then negative 1 divided by 4 would leave us with negative 1/4. Okay, so just because our number doesn't go perfectly into that 1, we can create a fraction that allows us to pull out that coefficient connected to the variable. So our factored expression would be 4 times c minus 1/4. Alright, this next one, we're going to factor out the 2.2 connected to the variable. So 2.2 is going to come out. 2.2 divided by 2.2 will leave us with just the w. And 6.6 divided by 2.2 would leave us with 3. So our factored expression here would be 2.2 times w plus 3. Okay, so these are examples for you to watch, and now I got a few for you to try on your own. Alright, so go ahead and try these 3 and then come back and see how you did. Remember, we're factoring out the coefficient of the variable, so the number right next to the variable. Alright, so the first one, we factored out the 5. So 5x divided by 5 will leave us with 1x. And negative 20 divided by 5 will leave us with negative 4. So our factored expression is 5 times x minus 4. So factoring out the 18, 18m divided by 18 would leave us with m. And 36n divided by 18 would leave us with 2n. So our factored expression would be 18 times m plus 2n. This last one, dividing by negative 3, that will leave us with positive y, and negative 8 divided by negative 3 will leave us with plus 8 over 3. So our factored expression there would be negative 3 times y plus 8